So we're picking up right where we left off. We were in the middle of this long problem where we're applying row operations to an augmented matrix, and I just cleaned up my written version of the last step here. So our last step that we had taken was we were just taking row 3 and multiplying the entries by 3/7. So the zeros stayed the same in the first two positions. The next position becomes 1. Then we get a 3/7. Then 3/7 times -7/3 is -1. So now we want to get a 0 below that 1. So we are going to work on row 4 and replace row 4 with row 4 minus 4/3 times row 3. So if we multiply the 1 by -4/3, add it to the 4/3 below, we'll get a 0 below. So let's look at what we have now. First row is the same. Second row is the same. Third row is the same. And the fourth row now, we still have 0 here, 0 here. We get a 0 in the third position because we have 4/3 minus 4/3 is 0. We're going to have 0 minus 4/3 times 3/7. That's going to be minus 4/7. And we're going to have 4/3 minus a -1 times 4/3 is, or -4/3 minus a -1 times -4/3. -4/3 plus 4/3 is 0. So now, as we move diagonally down through these 1s, we're down to the 4th row, and we want a 1 in this position. So we want to change row 4. We want to replace row 4 with, I'm going to multiply by a number to get a 1 in the position I just circled. So I need to multiply by -7/4. And that just makes one little change in what we got here. So a lot of recopying. So the first 3 rows are the same, and the only change is I will now have 0, 0, 0, 1, 0 in this 4th row. And so now we've gotten our 1s coming down this diagonal. We have 0s below. We're not done yet. This is something called echelon form. Sometimes we say row echelon form. Echelon comes from, I think the origin of the word has something to do with ladder. It's like we're coming down the ladder of these 1s. Now, we have 1s on this diagonal. We're happy to have these 0s below. That's what we've been working on. We're going to continue the process. We're not done yet. We're going to continue the process where we now want to get, we want 0s above the diagonal 1s. And to carry out this, we're now we're going to work from right to left through the columns. We're actually going to go back this way. We started on the leftmost column and worked our way over to the 4th column. Now we're going to start at the 4th column and work our way backwards. Now, we're buried in this problem that we got to get through pretty soon here. After we're through, I'm going to go back and talk a little bit about what all these steps mean as far as the equations, the original equations were involved. But I'd rather just finish up this process first. And so I've written so much on there. I'm going to recopy. I'm just recopying now, so I have some more room to write some comments. So we're going to work right to left. We're actually going to start in this column. So the last column where we got a 1 in diagonal position. And we want zeros above the 1. So we're going to change each row using a multiple of the fourth row, because we can make that fourth row 1 whatever we want. So for instance, I'm going to take row 1 and replace it with row 1 minus row 4. And I can take row 2 and replace it with row 2 plus row 4. And I can take row 3, and now this is a little bit more complicated, but not much. I'm going to replace it with row 3 minus 3/7 row 4 to get that 3/7 to become a 0. Now, I can do these three operations at once, because if I had done them separately, the result would be exactly the same. So here it's okay. If you're ever in doubt, do each one of these steps separately. So, okay, row 1 minus row 4. 1 minus 0 is 1. 1 minus 0 is 1. 1 minus 0 is 1. 1 minus 1 is 0. 4 minus 0 is 4. So we get just that one change. Row 2 plus row 4. So 0 plus 0 is 0. 1 plus 0 is 1. 2/3 plus 0 is 2/3. Negative 1 plus 1 is 0. That's really what we wanted to happen. 7/3 plus 0 is 7/3. Now, row 3, I'm going to replace with row 3 minus 3/7 row 4. So I have 0 minus 3/7 is 0. 0 minus 3/7 is 0. 1 minus 3/7 is 1. 3/7 minus 3/7 times 1 is 3/7 minus 3/7 is 0. And negative 1 minus 3/7 times 0 is negative 1. So that stays the same. And I have 0, 0, 0, 1, 0 staying the same in my fourth row. Now I move back. I back up to the third column, and I want zeros above the 1 in the third row position. So row 1 again I'm going to act on and replace it with row 1 minus row 3. I'm subtracting this one now. Row 2 I'm going to replace with row 2 minus 2/3 row 3. And that 2/3 minus 2/3 row 3 will get me a 0 in this position. So let's see what we got now. Row 1 is going to change. Row 1 minus row 3. 1 minus 0. 1 minus 0. 1 minus 1 is 0. That's what we wanted. 0 minus 0. Now, be careful, because there are some other changes occurring here. I am getting row 1 minus row 3 is going to be 4 minus a negative 1 is 4 plus 1, or 5. Now row 2 is minus 2/3 row 3. So 0 minus 2/3 0 is 0. 1 minus 2/3 0 is 1. 2/3 minus 2/3 times 1 is 2/3 minus 2/3 is 0. 0 minus 0 is 0. 7/3 minus 2/3 times negative 1 is going to be 7/3 plus 2/3. That's 9/3, or actually going to be 3. And then I recopy 0, 0, 1, 0, negative 1, 0, 0, 0, 1, 0. And I think I only have one more step to carry out here because I want a 0 above this one in the second column. So again, I'm going to act on row 1 and replace row 1 with row 1 minus row 2. I don't think there's any way to do all these steps together. You may be wondering why we keep acting on row 1 over and over again. So my row 1 now becomes just row 1 minus row 2. 1 minus 0 is 1. 1 minus 1 is 0. 0 minus 0 is 0 minus 0. 5 minus 3 is 2. Notice there's a change there. And then I recopy 0, 1, 0, 0, 3. 0, 0, 1, 0, negative 1, 0, 0, 0, 1, 0. Okay, now finally we're to this point where we have 1s coming down this diagonal, 0s below, 0s above. This is called reduced echelon form. It turns out, you can often find a solution to a system before you get to reduced echelon form, but it's going to be easiest to read off what the final result is from this reduced echelon form. So you definitely want to know how to get to this point. Now, what do we have here? What happened? Well, anywhere along the way, we can translate our augmented matrix back into an equation involving the variables. So here, for example, if I read this off as an equation, remember column 1 was coefficients of x1, column 2, x2, column 3, x3, column 4, x4. So this first line, this first row is 1x1 plus 0x2 plus 0x3 plus 0x4. That's just x1 equals 2. The second row, 0x1 plus 1x2 plus 0x3, 0x4 equals 3. And I think you can see what happened here. So the third row, I have x3 equals negative 1. And the fourth row is x4 equals 0. So this is the solution to the system. This is the unique solution to the system, meaning there's only one. So there is a solution. The system is consistent. That was the original question. And we finally finished that problem that I started. Let me see if I can pull up the original system of equations here. Actually, what I'm going to show you is something a little different, just to take up another minute or so. Like, what does this process have to do with solving equations? Like, what's the connection between the original equations we started out with? And I'm going to flash something up here on the screen and slide the pages by slowly. Here's our original system of 4 equations, 4 variables. Every step we've taken with the matrices can be interpreted as a manipulation of the equations. For instance, the first step we did, we can think of as having taken negative 2 times equation 1 and added it to equation 2 to get a new equation 2. So in the system we have the original equation 1, a new equation 2, and original equation 3, original equation 4. The next step, where we multiplied equation 2 by negative 1/3, gives us a new equation 2, leaving equations 1, 3, and 4 alone, as they were originally. And I'm just going to slide these pages by, because I went through each one of the matrix steps, and I wrote down what that meant as far as the equations were concerned. And eventually I got to this point where the equations looked like so, and they're equivalent to the original equations. This is the echelon form that we got to about halfway through. Then we continued manipulating, and if I did what would the corresponding steps would be for the equations. Eventually we get to here, and we end up with just the equations x1 equals 2, x2 equals 3, x3 equals -1, and x4 equals 0. So you don't have to be able to reproduce that, but I just want you to be able to see that everything we did with the matrix corresponds to manipulation of the equations that get us to the same result. And so that's the end of that problem. And finally, I'm going to stop this video. We're going to do one more example, though. I want you to see one more situation before we finish this section.